is going to be a little weird. All right, here we are. Live. For those of you in the chat, I see 2 or 3 people in the chat so far. If you would please leave a comment, that would be wonderful. In regards to this brand new full day class period, they have, as I'm sure you've seen in other classes, instituted a 23-minute remediation period. And the teachers have the option of taking that remediation period either at the beginning or the end. I'm going to opt to take it near the end. But it's specifically for the core classes, because like in my elective classes, I don't have to do this particular remediation that they're asking me to do with you guys. Typically, the way that it's going to run is something like this. On day 1, we would run back some sort of pre-assessment. The pre-assessment would be done on the Chromebooks through Linkit. Same thing with like what we did for other assessments, the benchmark, the midterm. I would provide you a code and you would knock out that pre-assessment. Now, based on what you get on that pre-assessment, which, by the way, it's like 6 questions for the math one, for the first standard, that is. It's 6 questions that you'd have 23 minutes to get done. If you are, or score high enough, let's say, whatever level they have you at, based on the pre-assessment, then they would allow you to work on enrichment activities. Now, these enrichment activities would be graded. If you don't score high enough, then you would have to work on remediation activities, in which, yes, these remediation activities would be graded. So regardless, they do have you doing these assessments. There's supposedly going to be 3 additional assessments on top of the ones that I typically do for a marking period during these remediation periods. It's this really messed up situation where the teachers are still asking questions about it. You know, when we received the last email in regards to remediation instructions? 4 p.m. on Friday. Yeah. Talking about the remediation. Yes. The remediation period, or the intervention period, as they have up here. What's up?
Oh, so lunch.
We're all coming from lunch.
Yeah, I thought I missed your 14 class.
No, we got work to do. I'm sorry, go ahead and say it one more time.
Wait, the intervention period.
Yes. The intervention period, which...
Like that weird 20 minutes?
Yes. Today, we're going to be knocking out a pre-assessment to determine whether or not you would be working on the remediation or the enrichment activity. I know. And then on Wednesday, on Wednesday? You know Wednesday's a half day, right? There you go.
I find it so weird. That makes no sense.
You're looking. No, I can't. I don't have the explanation. I have no idea why. But anyway, Wednesdays, as you said, are going to be the half days. Hold on. Which means that when you come in on Wednesday, there won't be a remediation period. So if I have you on Monday, Wednesday, Friday, your remediation periods or intervention periods will take place on Mondays and Fridays. If I have you Tuesday, Thursday, they'll take place on Tuesday, Thursday. Technically, no. If you have a half day before several days off, then contractually, unless they figure out some kind of workaround, contractually, the teachers are allowed to leave when the students are. They want the teachers to stay. Yeah, they did to Wednesday. I just told you why they can't do Friday. Yes, protests always work. So anyway. So,
I'm gonna just pull up like a petition, and then we just all say like we should just go back to half days, or else like 4 people get COVID and we're all out to go back.
You can do what you want, but until then, I'm still gonna keep doing what I'm doing. So, not to mention, if you have a petition with like a couple hundred signatures, you know what the Board of Ed's gonna do with that, right? Yeah. So, what I would like to do today. Now, the remediation period, like I said, 23 minutes. I'm going to take it at the end, which means at noon, we're going to have to begin this thing. Well, actually, a couple minutes before noon so that we can get set up. Today, you're going to be taking the pre-assessment. As I explained what that's going to do on the computer. I'll give you the code for that when the time is appropriate. Like the pre-assessment, just so you're all aware, the pre-assessment is not graded. The pre-assessment's not graded, but the pre-assessment is going to determine whether you do the enrichment activities or the remediation activities, which those would be graded. So just keep that in mind. But we're going to do that at the end of the class period. As for today, last class, I gave you an introduction to the ideas of graphing these rational functions. And now today, we are going to be deep diving some of the rules and some of the procedures that you would have to go through in regards to graphing these things. So if you would, if you do not already have them out, I'm going to need those notebooks out and open. Real quick, we got work to do. And again, just a reminder for those of you in the chat, if you have not left a comment, please make sure that you do so I can take that proper attendance. Now, I have several things open on my computer screen, including Desmos, which I will be jumping back into Desmos. Give you a small introduction to what is expected of you on Desmos, but we'll, again, deep dive that today. Today is the 26th.
It's like 6 days after the 20th.
Do you want an applause?
No, I'm just.
Oh, okay, go ahead, question.
Why don't you stream on Twitch?
I'm not a fan of Twitch, first of all. Second of all, you mean for for lessons?
Yeah, why?
Part of the reason why Twitch was not an option was because they wanted us doing something that was Google related. And YouTube is owned by Google, and you can log on directly with your school Gmail accounts. I know. Now, there are obviously other websites, like, for example, that you could sign up. There's like the button to sign in with Google, like that stuff. But Twitch isn't affiliated directly with Google. So that's partially.
Would you stream on Twitch, sir?
I mean, I'm not really a fan of it. That's why I don't really do it. I mean, I have an account. I have everything set up and ready to go. I just don't like it.
What do you stream?
Huh?
What do you stream?
A bunch of random stuff. Mainly, I stream video games.
Yeah, but I figured you mentioned you play video games. What do you they still like Mario Kart and stuff like that.
So let's talk about some of the things here. Typically, a rational function is in the form f of x equals. Now, these letters don't necessarily make a huge difference, but I'm going to use p and q. P of x divided by q of x. Typically, a rational function is in that form. P of x over q of x. The general idea is a single fraction in which the top of the fraction could be considered an equation, and the bottom of the fraction could be considered an equation. It doesn't really matter what these equations are per se, but let me just give you an example right here. An example being on top of the fraction x plus 4, and on the bottom of the fraction x minus 3. That's just one example right there. So whenever we're given a rational function, you're going to need to recognize it as a single fraction. If it is not a single fraction, then there are ways that you can bring them together to be a single fraction. That's what we've been doing for the past couple of weeks. Whether it be simplifying through multiplication division or simplifying through addition and subtraction. It doesn't matter. We can bring them together to be a single fraction like this one right here. Furthermore, P of x and Q of x have degrees determined by their largest exponents. Determined by their largest exponent. It is vitally important for you to identify what the degree of each part of that fraction is. What the degree of the numerator is versus the degree of the denominator. The degree, again, is determined by the largest exponent. In this particular example that I have in the middle of the piece of paper, in the middle of the screen, for that particular example, the degree of the top of the fraction is equal to the degree at the bottom of the fraction. Now, there are three situations that you could have in terms of the degrees. Three situations in which the top of the fraction has a larger degree, the bottom of the fraction has a larger degree, or in this case, the degree of the top of the fraction is the same as the degree on the bottom of the fraction. There are all sorts of different situations that we're going to have to deal with in terms of the degree, and I'm going to show you those. This one is probably the absolute most straightforward one. And I'm going to walk you through that. If the degrees are equal. If the degrees are equal, this is probably the absolute most straightforward way of dealing with this problem. If the degrees are equal, take the leading coefficients, divide them to get your ha. I'm going to tell you what ha is in a moment. If the degrees are equal, then take the leading coefficients and divide them to get your ha. What is your ha? Your ha is your horizontal asymptote. I'm going to walk you through a few of these examples so that you can see exactly what is expected of you on them. So let's actually see that. I'm going to bring up Desmos in a moment, and I'm actually going to put the example that I have on the paper up above into Desmos, and I want to show you exactly what Desmos is going to do in a moment. Now, just for the sake of argument, look back at this example right here. What is the leading coefficient of the top of the fraction? What number is in front of that largest x? Yeah. What about the bottom? Yeah. This is a very straightforward example. Oh, so the coefficient on the top of the fraction is a 1. The coefficient on the bottom of the fraction is a 1. So you're telling me that in this example, the degrees are equal. All I have to do is 1 divided by 1, and that's my horizontal asymptote? Yes. That's literally all you have to do for this example. Let me actually throw this into the calculator so you can see what it looks like. F of x equals parentheses x plus 4 divided by parentheses x minus 3. Now, I'm going to zoom out just a tiny bit right there so you can see it a little bit better. There we go. And I'm going to put in a horizontal line. Look at this horizontal line that I'm about to put in. When I put in this horizontal line, I really hope Desmos makes it a different color. 1. Yes, it made it. It was blue. Look at that blue line floating through the middle. This is the horizontal asymptote. The horizontal asymptote is an invisible barrier that the graph goes up to but doesn't cross. Now, there's a little bit of a weird thing to it. I'm only really going to be talking about the ends of that when I write down this definition. But you can see now this blue line is not a part of my graph. This blue line is not a part of my graph, but by definition, it is the horizontal asymptote. And you can see this graph basically flatlining at that horizontal asymptote. And back here, it's flatlining at that horizontal asymptote. This is what the definition has told us. If I go back to this definition real quick, if the degrees are equal, like we have in our example, take the leading coefficients, divide them to get the horizontal asymptote. And that's exactly what we have. I can also get something else. If you set the denominator equal to 0 and solve, you get va. Now you could hopefully use the context clues of what we've been talking about to determine what do I mean when I say va? Your vertical asymptote, yeah. Which is your vertical asymptote. I would strongly suggest that when you write these out, like in practice, just use the abbreviations. It's so much easier to write HA for horizontal asymptote and VA for vertical asymptote than to just write it out full. But you got to know which one you're referring to. You have to know which one you are referring to. So now, you take the denominator, you set it equal to 0 and solve. Well, I'm going to look back at this denominator right here. If I look back at this denominator, the denominator is x minus 3 equals 0. This is going to be the easiest question all day. How do I solve that? What do I do to solve that? Yay! I don't know how long you guys have been doing. That's math. We did it. We did it, crew. But that is your vertical asymptote. Now again, your asymptotes are technically supposed to be invisible barriers. And when we draw them on paper, we can typically draw them as dashed lines. I'm going to go back to Desmos, and I'm going to change this y equals 1, and I'm going to change it to an x equals 3. There is my vertical asymptote. It performs the same exact function. It performs the exact same function as the horizontal. It does. Where the graph just kind of goes up to it and flatlines in a vertical direction. And on the other side, it goes up to it and flatlines in a vertical direction. That is exactly what these graphs do. When you are faced with an equation, you are going to have to do several things. Number one, identify a horizontal asymptote. Number two, identify a vertical asymptote. Number three, you can identify some x-intercepts. Go back to here, click. So I said if you set the denominator equal to 0 and solve, you get your va. If you set the numerator equal to 0 and solve, you get the x-intercepts. If you set your numerator equal to 0 and solve, you should be getting your x-intercepts. And that's exactly what we're going to do with this example in a moment. It's like decoding the entire equation. So I'm going to bring back the same exact equation, the one that we've been doing right here. I'm going to take that numerator and I'm going to set it equal to 0. This is now the second easiest question you're going to be faced with all day. Oh, I just subtract 4. Yes. And that is your x-intercept. You have to label it accordingly. And if I go back to Desmos one more time, wait, where is it there? Oh, I'm sorry. Yeah. Where is Desmos? Boom, right there. I'm going to try and zoom in on that spot. You can see it right there, hopefully. -4, 0. That is the x-intercept. The crazy thing about this graph is that nowhere else does it cross the x-axis. That is the only spot that actually crosses the x-axis. We're going to graph this thing. We're going to graph this thing by hand. It's got to be phenomenal. So that's the note that I had before. If you set the numerator equal to 0 and solve, you get the x-intercepts. So let's actually do this thing. In your notes, I'm going to rewrite the exact same equation. X plus 4 over x minus 3. We were able to identify a horizontal asymptote. This is what you would then write down. You would write down that your horizontal asymptote was y equals 1 based on the work that we did. Your vertical asymptote was x equals 3, which is what we wrote down earlier as well. And your x-intercept was x equals -4, based on all that stuff that we did. There's only one more thing we got to do. We need a table of values. You are not to calculate a table of values by hand. Oh my gosh. Don't do it by hand. You have technology, don't you? Use your calculators to do it for you. So that's exactly what I'm going to do right here. Now, you could go to Desmos, or you could go to the graphing calculator that you have on your computer. If you go to y equals, and you type in the equation exactly as it appears, x plus 4 divided by x minus 3. Of course, you could graph it, but that's not what I'm really interested in. What I'm more interested in is second graph. That is what I'm interested in. I'm interested in second graph. Now, I don't want to write down all these numbers. Instead, the note that I am going to give you to write down is to create a table of values going at least 2 ordered pairs to the left of the error and to the right of the error. That's honestly all you have to fill out of a table of values. Let me copy this down, and then I'm going to show you what I copied down. So table of values, I'm going to copy down 1 and -2.5. I'm going to copy down 2 and -6. I'm going to copy down 4 and 8. And I'm going to copy down 5 and 4.5. So let me show you what I wrote down. That's what I wrote down. That's all that I wrote down. This is all the information you need. This is it. If you have these pieces of information, you can graph this thing on paper. That's all you need. A couple of points to the left of the error and to the right of the error. Now, as a side note, what is this error right here? What is this error? Why is there an error here? It's your vertical asymptote. If you plug a 3 in, you get a 0 in the denominator. Because it's like 3 minus 3 in the denominator. Yeah. So that's all you really have to focus on. I'm going to graph this thing by hand. But that's all the information I need. Identify a horizontal asymptote, identify a vertical asymptote, identify the x-intercept, get the table of values from the calculator, and then you can draw this thing. So let's actually do that. Hold on. Create a little XY plane here. Now, first I'm going to put my my asymptotes. There is my vertical asymptote. Again, I'm putting that dashed line because it's supposed to be invisible. There is my horizontal asymptote at y equals 1. The asymptotes actually split up the grid into like another 4 quadrants, which is weird. But I'm really only going to be focusing again on the other pieces of information. Right there, there's my x-intercept at -4. And now I'm just going to plot the rest of these points here. Let's see. 1, 2, 3, 4, 5, 6. There's 2, -6. There's 1 and -2.5. There's 4 and, well, 1, 2, 3, 4, 5, 6, 7, 8. There we go. And then there's 5 and 4.5. 1, 2, 3, 4 and a half. Now I'm about to draw this thing, but that's enough information. That is more than enough information to draw this thing out. The graph is going to flatline with the asymptotes. So if I were to start over here, the graph is going to flatline in the vertical direction. And then going to the left, it's going to flatline with that asymptote. They're either going to flatline in a horizontal or vertical direction. Well, unless we get to a different example, which we'll get there. Now up here, it's like, what the heck? You just have like 2 ordered pairs up here. Yeah, you got 2 ordered pairs up there, but that's enough information to do this. Because this thing is going to curve down and then flatline. That's sufficient for the right side. And then going in the other direction, well, it's just going to flatline up there as well. This is sufficient for graphing a problem. Right here. All of this junk. Insane. Now, there was an example that we did. There it is. There was an example that we did last class that I want to walk you through. I'm going to walk you through every part of this. It's going to be amazing. Well, mainly for me. Not for you. Are you sure? Was he making an inappropriate joke? Someone explain it to me.
What did you say again? What did you say?
I don't know. I don't remember. It went by so fast.
Lord did. You want me to explain that one to you?
I don't understand how humor works.
You don't understand the joke?
No, he doesn't. It's because he's a math teacher.
That's what obviously he knows.
My boy was the president of a fraternity. I already know.
What?
You were definitely the president of a frat. I can tell you were definitely like the party animal in college.
You know nothing about me.
Definitely a party animal.
Just Google me. You'll find a famous trombone player.
No way.
What?
Come
Oh
on,
my God,
please.
musical artist.
No way.
From England,
You were that guy.
No, that's not even me. Look.
I know.
Oh,
Very
no, that-
Famous trombone player.
No, search up James Markey Jr. of Market, New Jersey.
Do it on your own time.
Wow, they're right now.
I got work to do. All right.
Markey Jr. Markey Jr.
You're the third one to come up. You're like, I finished it. It says, is your phone number 6983687?
No, that's my parents' old number that they disconnected. Yeah.
I got your address for your parents.
Is your Twitter
Yeah, I tell you, they live in Settlers.
Is your Twitter? Wait. Is your Twitter Mr. James 113083?
Yes, but if you go to it, there are exactly 0 tweets.
There are 9 records found.
You gotta find your IP. Find his IP.
Hold on. I'm gonna get your
Put him offline.
All right, but back to this, because I'm continuing with this example. Ladies and gentlemen, this example right here is the example that we did last Thursday. Now, last Thursday, I challenged you to take this example and to put it into Desmos to make sure that you could type it in correctly. Now, today, we are going to go through this piece by piece with those directions. If you notice, the degree of the top of the fraction, what's the degree of the top of that fraction? Well, hold on, answer my question.
You got 5
Wait, do you live at 419 Lighthouse Drive?
Yeah, I thought everybody knew that.
What?
I thought everybody knew that.
You told me that.
You have 5 stars. You're a good teacher.
Okay, but does anybody remember that?
Anyway, back to this. Answer my question now. I answered your question.
Okay.
What's the degree of the top and bottom of this fraction?
Positive. Negative.
A degree is the largest exponent. There we go. So, being that the degree of the top is 2 and the degree of the bottom is 2, they are equal to one another. This is one of those 3 cases that I talked about. Being that the degrees are equal to one another, if we wanted to find the horizontal asymptote, we would have to take the leading coefficient of the top and bottom and divide them. Now, one thing I will point out is the fact that factoring would have to take place for a lot of this stuff, but I'm going to leave that for a future example. What is the horizontal asymptote of this particular example? What is the horizontal asymptote of this particular example? Say again? Not 1x. Now, I'll go back to the directions of it. Let me actually go back in my notes to that page. If the degrees are equal, which they are, take the leading coefficients and divide them to get the horizontal asymptote. Well, what is the leading coefficient of the top and bottom?
2, 3, -2.
Leading coefficients of top and bottom.
I see. Okay, 1 and 2. Yeah.
Leading coefficients.
Yes, sir.
If they're equal, if the degrees are equal to one another. Then
Say it's a 1x and 2x squared, then I would.
they wouldn't work exactly like that. No, it would not.
Gotcha.
There are specific directions for that, but we'll get to that. Now, let's say I wanted to find my vertical asymptote. If I wanted to find my vertical asymptote, let me go back to my directions real quick. It says in my directions, if you set the denominator equal to 0 and solve, you get the vertical asymptote. Okay, so let me take the denominator, do a little vertical asymptote work right here. Let me take my denominator and set it equal to 0. How do I solve that? Ooh. Now we run into a bit of an issue. Finding the horizontal asymptote, those directions fit perfectly. Finding the vertical asymptote, all of a sudden, holy crap. How does one find a vertical asymptote with this particular denominator? More of a quest. Not much of a quest. You just have to factor. And then we can solve. Let's go to A times C to get -6. Let's find two magic numbers at -3 and +2, because what do they have to add up to? What if they have to add up to? Yeah, because look at that B value in the middle. Look at that B value in the middle. There we go. It focused. Yeah, which is a -1x. So they have to add up to -1. Put my magic numbers in the T-chart with a 2x and a 2x. This is stuff that we've been doing since September, stuff that I reminded you at the beginning of this chapter. Simplify that junk down. You end up with a 2x minus 3 and an x plus 1. This we have to solve. This is stuff that, again, we've been doing since September, October. Solving quadratics by factoring. In order to properly find the vertical asymptote, you would have to solve something like this. And if you solve this correctly, you get a value of 1.5 and a value of -1. What the heck? How come I got two answers? There's two different little factors right here. Yes. So what does that mean for my vertical asymptote? Yes. Say it one more time so everyone can hear you. Two different vertical asymptotes. Yeah. You're going to have a vertical asymptote at x equals 1.5, and you're going to have a vertical asymptote at x equals -1. Insane. You would also have to find x-intercepts. And in order to find those x-intercepts, again, I go back to my directions. If you set the numerator equal to 0 and solve, you get the x-intercepts. So let's set the numerator equal to 0 and solve. I'm going to label my work x-intercepts, x squared plus 2x minus 3 equals 0. Now, this one's a little bit nicer because it's a 1x squared. But basically, I don't have to go through the full Tucker method. You just have to find the two numbers that multiply to -3 and add up to +2. This marker's dying on me. Oh, if that paper dispenser wasn't there, I would have made it. Has anyone even used that thing? No. It's all the way over there. Anyway, if I solve this, I get an answer of -3 and +1. Those are my x-intercepts. Let me recap exactly what we just did. We're going to graph this thing by hand. We will, and then we're going to compare it to what the computer says. We are going to graph this thing by hand, though. But let me write that information down with everything else that I had on the previous page. On the previous page right here, I got these pieces of information to the left. And I got an x-intercept at -3 and +1. Let me recap exactly what the heck just happened. You're given that equation at the top of the board. Now, there is a bit of a factoring that may have to happen in order to determine. So I'll show you that factoring in the future. But if you take the leading coefficients and divide them, you're going to get the horizontal asymptote. That works if the degrees are equal. Take the denominator, set it equal to 0 and solve. The denominator equal to 0 and solve will get you your vertical asymptotes. The numerator equal to 0 and solve, you will get your x-intercepts. Now I just need a table of values. But where am I getting this table of values from? No, not your brain. On the computer, on the calculator, on the table of values. I'm going to go over here. I'm going to type in that information. Let's see. X squared, make sure you tab over to the right, plus 2x minus 3, close the parentheses. Make sure you're typing these in correctly. Divided by parentheses. It was a 2x squared. Oh, I got to go back on this one. X. Come on, you. I got to go back over to this thing. There we go. Squared. Boom. Minus x minus 3. Close parentheses. Looks good to me. Let's go to the table of values. Boom. Oh no. I don't see where any of the errors are. Lindsay, you said it before. Where are my errors supposed to occur? Well, there's one error right there. Why is that an error? It's for anybody. Vertical asymptote. The other error doesn't show up. Now, -1 is a vertical asymptote. -1 is a vertical asymptote. But what is the other vertical asymptote? Yeah, which doesn't show up on my table of values, huh? But that's okay. Even though it doesn't show up on my table of values, I can still deal with that. So I'm going to copy down a table of values here. I'm going to copy down a table of values here, and I'm going to show it to you in just one moment so that you can see exactly what it is that you're going to do here. I am still going to write down ordered pairs, a couple to the left and a couple to the right. There we go. That's what I wrote down. That's all that I wrote down. A couple to the left of -1, a couple to the right of -1, a couple to the left of 1.5, a couple to the right of 1.5. That's all that I really need to draw this thing out. All of this information, the asymptotes, the intercepts, the table of values, that's all that I need. And we can draw this thing out exactly the way that it's supposed to look. And then after we draw it out, I'm going to compare it to what Desmos says. Now, we've seen this before. We've seen this example before last Thursday, but I'm going to bring it back up on Desmos, or even on the calculator, really. But let's draw this sucker out. Get a whole new page for this one. Make it large enough so I can actually see everything. Here we go. Let's see. First, I am going to do my horizontal asymptote. Now, my horizontal asymptote was at 1/2. So I'm going to put that dashed line at 1/2. There we go. It's not perfect, but it'll do. My vertical asymptote was at 1.5. Halfway between right there, that's sufficient. And at -1. There we go. There are all of my asymptotes, which actually break the graph up into like 6 different sections. That's okay. We'll figure this junk out. X-intercepts are at +1 and at -3. There are my x-intercepts. All right. -2 and like a -0.5 almost, so it's like right there. 0, 1, 2, and like 1 and change, like right about here. And then 3 and 1. This is enough information. But you have to know how this graph actually works. You have to know how this graph actually works. I'm going to show you this graph in a different color. I'm going to do it in red on the board in a moment. That was a terrible. I don't know what that hit. Anyway, on the left side. On the left side, this graph flatlines like that. And flatlines like that, just like we did before. Absolutely, yes. That is exactly what that side of the graph does. It's going to flatline at those vertical asymptotes. Over here, it's going to do the exact same thing. It's going to flatline there and flatline there. That's exactly what that graph is going to do. It is going to flatline at those asymptotes. In the middle, it's still going to flatline at the vertical asymptotes, but it's actually going to ignore the middle one. This is one tiny little exception to the rule. Yeah, it's like it does one of those. And I'll show you that on the computer in a moment. It's still going to flatline the way that the rules say for vertical asymptotes, but it's going to ignore that horizontal one in the middle.
So for the questions today, are we just going to be like graphing the asymptotes?
Oh, for the pre-assessment?
Yeah.
The pre-assessment is on 3 standards that are unrelated to what we're doing at the moment. Yes, the pre-assessment that you're going to be doing is based on information from the past that they're hoping to be like, okay, well, how much did they retain? Yeah. I mean, I may have some stuff in common, but so let's take a look at Desmos. I'm going to erase this, take a look at Desmos before I actually draw this thing in for real. Actually, no, I want to look at the graphing calculator first. It already has it typed in. Graph! Oh, it has AP stat stuff on it. Hold on. Zoom 6. There we go. There it is. It does exactly what we expected it to do. It flatlines the way we expected it to on the left and the right. In the middle, it did that weird wonky thing that you referred to, but that's exactly what it's supposed to do. It follows all of the rules that we set forth. Now, actually, let me draw this on paper. And then I want to show you the last thing I want to show you today. Because graphing is going to be a multi-class period thing that we're going to be doing. That was a fun noise. That's what I just drew out right there. Looks terrible, but that's what it looks like. Now, I need you to write down these 3 cases for the degrees. 3 cases for degrees. Three cases for degrees. Case number 1. Degrees equal, question mark, divide leading coefficients to get ha. Notice the abbreviations that I did right there. I would prefer that you write down these abbreviations. If the degrees are equal, then you need to divide the leading coefficients to get ha, your horizontal asymptote. Case 2. Denominator has larger degree. if the denominator has the larger degree, then your ha is y equals 0 no matter what. If the denominator has the larger degree, Declan, I think you asked this example earlier, then no matter what, your horizontal asymptote is y equals 0. No matter what. And I'll show you a visual example of that in a few minutes. The third example is just if the numerator has larger degree, then this is actually a very, 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 very special case. There is no, oh yes, question. Give him a moment to get back. If there is no horizontal, there is no horizontal asymptote, but there is a slant asymptote. Now, I'm not going to talk about slant asymptotes today. I am not going to talk about or teach slant asymptotes today. I wanted to teach case number 1 in its entirety. But just so you know, if the degree is larger on one side of the denominator or the other, these are the special cases that actually end up happening. And you're going to see that. I'm going to show you visually, but I'm not going to actually have you. Draw it down. So I'll leave that up there for a moment. But then I'm going to jump to Desmos just to show you these examples, these visual examples for this thing. Let's see what happens. Desmos. Let's see. Make that larger. There we go. So let me change this to, I'll change the bottom to an x squared. Check this out. X squared. If I change that to an x squared, now the denominator has the larger degree. Look at that horizontal asymptote. Right there in the middle at y equals 0. There's the horizontal asymptote. If the degree on the bottom is larger, it's always y equals 0 no matter what. But let me change that where the top now is squared. Oop, there it is. Yeah. Now, if you look at that, I'm telling you right now, this particular graph, this is when the top degree is larger. This thing does not have a horizontal asymptote. Instead, it has what is called a slant asymptote, where it's not really flatlining at a horizontal. It's actually just following the trend of some kind of slanty thing. It still has a vertical one that you can see right there. But the horizontal one is now slanted. But again, those examples are not for today. I just wanted to visually show you those, and we'll get into those in the coming class periods. Today's focus was just on if they were equal to one another. Okay. For those of you that are in the chat and for those of you that are here, if you do not already have them out, you need to have those Chromebooks out and open, and you need to get on to Linkit. Barnegat.linkit.com. I need you to get on there as quickly as possible. In reality, I got to give you the test taker code, or not the test taker code, the test taker link. Let me get that link real quick, because if you go to barnegat.linkit.com, it's not going to work the way that you want it to. Let me see here. Here we go. There it is. I'm going to copy that into the live stream post. There it is. In the Google Classroom live stream, there is the test taker link that you have to click on, and it will take you right here to assignment code. I have the assignment code ready to go. We're supposed to be starting this at approximately noon, so we're a couple minutes early. So for those of you in the live chat, you need to get onto that code as quickly as possible. This is a pre-assessment for math. No. I explained the whole pre-assessment thing this morning when you came in.
Yeah, no, that was also an hour ago.
Yes, it was an hour ago.
My brain doesn't go back.
Ah, goodness. Now, like I said, this pre-assessment does not count against you. This pre-assessment does not count against you. But it will determine whether or not you are going to be working on the enrichment activities during this intervention period, or if you're going to be working on the remediation activities for this intervention period. And regardless if you're doing enrichment or remediation, they're going to be graded. But the pre-assessment is fair game. You do what you do. And then we'll kind of go from there. So you got to make sure that you are on this particular page. And then I'm going to switch my screen over so that you can see what you need to look at. That bell, I don't know what that bell is for.
So if we don't finish this, then we don't do that.
If you don't, well, it's only 6 questions, first of all. Second of all, if you don't finish it, you have to submit what you got and the rest are wrong. Keep in mind the pre-assessment does not count against you, but it will determine what path you take in the future intervention periods. I know it sounds like, like a 5-year-old came up with the system. Maybe they did, Again, you say our school system, it's every school system doing something slightly different. Grass is always greener. Let's flip this thing over to the code. Now, when I show you this code, you'll enter the thing, you'll see the list of names. You find your name, your password should be your student ID number. Once you enter that thing, you can get started. You can absolutely get started once I show you what this code is. Click, there is that code right there. I'm going to type this code into the YouTube chat. I'm going to type this in just in case you can't see it that well. But it should be 001. If I can actually get back onto YouTube real quick. There we go. 001 YERJ1. That's what this thing should be. Let me get over. Oh, come on, chat. There we go. I got back in. So 001 YERJ1. Yep. And you have the remainder to get it done. Let's get them going. We gotta get this pre-assessment done. Come on, we gotta get this pre-assessment done. Oh, we gotta get this pre-assessment done. Yes. In your Google Classroom stream, there's a link to go find the Lincoln test taker, and the code is on the board. Remember, it is 6 questions. Take your time. You have until 12:23. And just a reminder, this does not count against you, but it will determine what you end up doing in the future, whether it be in being the remediation or the enrichment. the Google Classroom stream, there's a link to get to the test taker. We got to use this code. You guys have until 12:23. Yes.
Is it nice out?
Hmm.
Is it nice out?
I don't know. I haven't been out since about 6:50 this morning.
Is our password just like BTS number?
Your school ID number without the BTS. there's already a magnet. Okay.
That was so annoying. One, three. We finally did it. What do you want to know? So why do you find out, like, that's what I was gonna say. I mean, like, obviously then how to get this, like, if you ask it.
Good call. I can tell you guys almost immediately what score you got on the thing. But in terms of like whether it's remediation or enrichment, that I won't know for like maybe a day or so. So I'm gonna check the computer right now.
What do you think would, like, how many you would have to get wrong to where you would think that it would have to be initiated?
Let me take a look.
You don't know?
I think it would also depend on what the group got as a whole. For example, if oh, you okay?
Like if everybody got three wrong.
Yeah, then that would be something where we'd have to have, yeah. So let me take a look.
But if it was like 5 versus a class 3, then you'd have to get one help.
Let me see here. Review. Oh wait, that's not where I go. I'm sorry. I gotta go to dashboard. All right. Shh, 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 shh. Other people are trying to focus, and I'm trying to focus. Oh, interesting.
That's scary. So the average is 1 out of 5. And Wesley all got all of them wrong.
The computer splits you guys up. It does it automatically. I didn't set these scores, but the computer automatically assigns you into one of two groups:
Oh, that's
mastery or non-mastery.
mastering out of 6. Serious?
Yeah.
So if you didn't get all 6 right, you can do
It looks like in order to meet mastery, you would have had to get either 4, 5, or 6 correct.
Did anybody getting that?
About half so far.
Yeah.
About half.
He's like, not just. He's like, yeah, not you. You're an idiot.
That's why I just thought it was interesting that it was exactly half so far of the ones who have submitted. Now it's a little more than half. No, right now it's like of the people who have submitted, 55% hit mastery and 45% so far have not.
That is not very accurate.
No, I understand that. But again, this one didn't count. It was to assign you into one of those two groups, either those working on enrichment or working on remediation.
You're different every day, right?
Well, this we'll have another pre-assessment like in a future class period for a different standard.
Oh, so to get non-mastery, do non-mastery for like the next month.
Not the next month.
So like
No, for like the next several intervention periods.
So like depends on like the lesson kind of.
Yeah, it depends on the standard that
Just
you get.
make sure that- That's so dumb.
I didn't come up with them.
I know that. Damn. If you came up with it, it would be a little bit
Wow.
dumber.
Promotion.
Let's see here. Because obviously there are those of you that are in the class taking it, and there are supposedly those of you taking it online. Well, we're up to 58% meeting mastery.
did that so impressed.
Oh. Were you using one of them old style typewriters?
No. It's 2021.
Just saying. Old style typewriters are cool.
That will not sound very ignorant.
That really did.
It's 20. Are you guys using a
He said
typewriter?
You
Scott.
never know. Like,
No.
like anybody could. It doesn't matter. Like, they're not as common, sure, but
I would love it.
When he said that, part of me hurt inside.
I would love to use one of those old typewriters. It would be so cool to like, if you had something to like write.
You never know. I had a friend who
oh, you did? That's so weird.
just one, only one my entire life,
That's so crazy.
and he was sending out thank you letters for something that had an event that happened in the past, and in his mind, in order to make it more personable, he had actually purchased an old style. Well, it was a replica, of course, but an old style like typewriter where you actually had to have the ribbon on there and like actually press it down, and some of the keys were like off kilter by like a little bit, and he hand typed these letters to people. You know, it meant more just because of the amount of time that he took to put that thing together. So
If I were like a crazy person, I was gonna like write my manifesto, I would use a typewriter.
gotcha.
Has more meaning.
So I'll tell you that in terms of those who have taken it, oh come on, get back to the screen. I gotta get back to the screen. Hold on. We had a lot more hitting mastery than not. Now, obviously, I'm not going to broadcast your information.
On your broadcast line.
I'm not going to broadcast your information. But if you would like to know, I'm going to sign off on the live stream, by the way, just so you know. But if you would like to know, I can show you or point it out to you. But I'm going to sign off on the live stream. If you have not left a comment in the chat, please make sure that you do so. I've already emailed those who have not taken the pre-assessment. We need to get on top of that.